Hey there, we're going to move on to lesson 2.4 where we're going to be writing equations of lines. This is kind of fun. So our objectives today are how do I write an equation? How do I write an equation given the slope and any point on the line, any point? How do I write an equation given any 2 points on the line? How do I write an equation if I know the slope and specifically the y-intercept? There's a little shortcut for that. And how do I write an equation given the y-intercept and any other point on the line? So those are kind of like the parameters that we're going to try and work through today. You guys ready to go? Here we go. Write an equation given slope and any point. So when we write an equation, our goal is always to get it in slope-intercept form. But depending on what you're provided, you might have to start with the point-slope form. So I'm going to kind of develop the point-slope form for you. This was developed or discovered by a gentleman by the name of Rene Descartes. He is credited for developing the formula for slope and the slope-intercept form and the point-slope form. So what he did was he took the formula for slope and instead of plugging in 2 concrete points, he plugged in some general points, namely x1, y1, and then xy. He used this for x2, y2, all right? So he's a brilliant man. He's like the mathematical rock star of modern algebra and analytic geometry. This guy's a powerhouse, okay, Rene Descartes. Cartesian coordinate plane, lots of really cool stuff that he was brilliant. And not only was he brilliant analytically, but he was philosophically, he was a leader, not so much like what he thought was super on track biblically, but he was a premier thinker of his day. So let's go ahead and follow what he did. I'm going to change my pen here. So here's my formula for slope, but I'm going to plug in y minus y1. Okay, y is my second coordinate, y1 is my first coordinate, and then I'm going to plug in x minus x1. And what this little sneaky guy did was he says, I wonder if I take this denominator and I multiply both sides by it, then things are going to cancel over here. All right, and over here I have m times x minus x1 is equal to y minus y1. Does that look familiar? It's just kind of symmetrically the opposite way. So if we use this symmetric property, we get y minus y1 equals m times x minus x1. So that's the development of it. I don't know if you've ever seen that before, but I think it's pretty cool. Descartes was a really brilliant guy. You know, like he rocked the mathematical world. He was awesome. So the good thing is that we don't have to develop it. We don't have to develop it anymore because we can now just use it. So if I'm looking for an equation in slope-intercept form, and I know the slope and I know the point that's not the y-intercept, then I have to start with the point-slope form. You can use this for every type of equation you're trying to find. Y minus y1 equals m times x minus x1, all right? Plug in. Y minus a negative 1 is plus 1. M is 4. X minus 3. We're going to distribute. Y plus 1 is equal to 4x minus 12. We're going to subtract 1 from both sides, isolating y, and we get 4x minus 13. And that's the equation of the line with slope 4 and going through the point 3, negative 1. Okay? So why don't you go ahead and hit pause, calculate this. The question on the video is going to ask you to supply the answer to this. So go ahead and do it and then come back. All right, here we go. I'm going to work it out for you. This is not the y-intercept, so I'm going to start with y minus y1 equals m times x minus x1. I'm going to plug in my values. Y minus 5 is equal to negative 2 times x minus 1. I'm going to distribute y minus 5 equals negative 2x plus 2 minus 2 times minus 1, and then I'm going to add 5. And so I get y isolated is negative 2x plus 7. And that's the correct equation for the line. It's in slope-intercept form, slope negative 2 and through the point 1, 5. All right, what happens if we aren't given the slope, but instead we're given any 2 points on the line? Well, all we have to do is a step previous, and that's calculate the slope. So label your points, calculate slope, and we get negative 3 minus 7 over 3 minus a negative 2, so that's 3 plus 2. And so we get negative 10 over 5, and we get negative 2. Now, we want an equation in slope-intercept form, that should be form, but we don't have the y-intercept, so we have to start with point-slope form. So we're going to go y minus 7 is equal to negative 2 times x plus 2. We're going to distribute y minus 7 equals negative 2x minus 4, and we're going to add 7, and we get y equals negative 2x plus 3. And there is our equation of the line that contains the points negative 2, 7, and 3, negative 3. So go ahead, you try this problem, and then when you're done, the video will ask you for your answer, and then you can come back and check it. All right, let's go for it. I have to calculate slope. So it's y2, it's my delta y, divided by my delta x. And so I get negative 1 minus 5 over 1 minus 3. That's negative 6 over negative 2. That gives me positive 3. All right, and now I'm going to plug in, and I'm just going to use this first point. So I have y minus 5 is equal to 3 times x minus 3. It's time to distribute. Y minus 5 equals 3x minus 9. And now I have to add 5 to isolate y. Y equals 3x minus 4. There's my equation in slope-intercept form for the line that contains 3, 5, and 1, negative 1. Pretty easy, right? All right, and this one's even easier. Writing an equation when we're given the slope and the y-intercept. All right, so again, Rene Descartes is the one who developed the slope-intercept form, y equals mx plus b. And what he did for this one is he used the formula for slope, but he plugged in the y-intercept, which we call 0, b, and xy. So we're going to go ahead and do it. We're going to develop this so that maybe it'll stick better. So now I'm going to go and I'm going to do y minus b over x minus 0. I'm going to simplify that denominator, and I get m is equal to y minus b over x. Now I'm going to multiply both sides times x, so I get it out of my denominator. These are going to cancel, and I get mx is equal to y minus b. So I'm going to add b to both sides and use my symmetric property. Y equals mx plus b. This is my slope, and this is the part of the y-intercept, 0, b. There's Rene again. Isn't he a rock star? So let's use it. All right. Write an equation in slope-intercept form given the following slope and y-intercept. Whenever you're given the y-intercept, you can go straight into slope-intercept form. Y equals mx plus b. If you're not given the y-intercept, you can't go straight into this form. You must start with point-slope form. And now we're going to plug in. So y equals 3 times x minus 4. And that's as simple as it gets. Okay? It's plus a negative. That means it's minus. It's a negative. So why don't you hit pause and you go ahead and do number 2, answer the video question with your solution, and then we'll go from there. All right? Hopefully you got that. So y equals mx plus b. Y equals negative 1/2 x plus 3. There we are. See how easy it is when we're actually given the y-intercept? It's super easy. If you forget, always use the first method because that will work on any point. The second method, the slope-intercept form, that only works if you're given the y-intercept. Okay? So now let's look at a situation where they don't give us a slope, but they give us 2 points, and one of them is the y-intercept. One of them is the y-intercept, okay? So we have to calculate the slope. So we get the change in y, y2 minus y1 over x2 minus x1. So we get negative 1 minus 2 over 0 minus 3. That gives us negative 3 over negative 3. That's a slope of 1. So m is equal to 1. And then we're going to go straight into slope-intercept form. Y equals mx plus b. I can do it because I have this. I have the y-intercept, 0, negative 1. Right? That's the y-intercept. So I get y equals 1x minus 1, or just x minus 1. So think about this. Why can I go straight into slope-intercept form? Well, because I'm given the y-intercept. And I can tell it's the y-intercept because it's 0, a number. 0, b. I'm given that point. All right, so go ahead, hit pause, solve this one, and then answer the video question, and then we should be good to go here. Okay, here we go. M, change in y, delta y over delta x, change in x. So I get negative 3 minus 2 over 0 minus 4. That gives me negative 5 over negative 4, which gives me positive 5/4. All right, and now I'm going to use my y-intercept. All right, I recognize it because it's 0, a number, and y equals mx plus b. I can only go straight into this method when I'm given the y-intercept, then y equals 5/4 x minus 3. Plus a negative is minus. All right, so here's going to be our daily assignment. It's going to be a piece of cake. I'll see you tomorrow in class. Thank you for listening.